Hey everybody, this is Larry. This is me over Q4 of the weekly contest 340. Minimum number of visited cells in the grid. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, it's going to be another classic Larry complaint about Python. I start these with a little bit of a retro of what happened during the contest, because I did do this problem during the contest. So if you are just looking for the straight, explanation, just fast forward a little bit. Look, you have the technology. You don't need me to kind of tell you to fast forward. You know how to do it. Just press the button, press the right button, go over 10 seconds, keep going. And I don't know. I believe in you. Now we wasted like 20 seconds telling you how to use the fast forward button. So please don't leave that comment on. Well, I don't know. Maybe leaving a comment helps the algorithm. I don't know. But in any case, that aside, I believe in you. You're smart enough at home. Press the button to wherever you need the explanation to be. I will start with the retro first. Is that so I actually have not four wrong answers, but just time limit on this. The TLDR is that this first time limit should have been this wrong answer, because I actually misread this problem. I misread this problem about going right and downwards. I thought you can go up, down, left, right. So that was actually a legitimate mistake by my part. But because of this TLE, I actually spent a lot of time, about 12 minutes, optimizing for it before I realized that I misread the problem, because I was like, how do I optimize for this, right? And the thing is that it's Leetcode Python, right? If I saw this TLE, if I was confident about Leetcode and Python, and at some point, to be honest, this is on me, in the sense that, like, Larry, why are you still using Python, right? And that's a good question. Maybe I need to really not. But in any case, so that was my door logic. I think this one's in C++. I made one optimization, but that's the thing with Leetcode and Python, right? Or Leetcode in general, with this sum of execution test thing, is that you don't know if one optimization is good enough, right? You just don't know, because you don't know how much you're off by. And because if you just do the complexity, everything's right. You do the complex analysis, and it's like, okay, well, maybe it's a little bit slow. Maybe the constant's a little bit high. Like, what's the difference between, you run the max case on locally, or not even locally, but you run the max case on the machine, and the max case takes 1 second. Is it fast enough? Who knows, right? How many test cases do they have? And there's no way to tell. And they've been promising this for about 2 years, maybe, at least, maybe longer. At the least they can do is just, make the Python bounce a little bit better, but they haven't. And so, in any case, it led to a lot of things where eventually I did realize that I read it wrong. And because fixing this from going right and down to up, down, left, right to just 2 direction was actually pretty quick, right? And I'll show you in a second, but it's like a 10 character fix or something like this. I don't know, right? So I got it very quickly afterwards, but not before 4 wrong answers. And I kind of converted this in C++ as well. So this wrong answer was actually legit, but because there was a hidden test case, and I was just so wasn't sure about this Python that I didn't know if this was like a real wrong answer or an optimization wrong answer. And because I used ChatGPT, to be honest, to convert my code from Python to C++, I wasn't sure it was just ChatGPT, but it turned out they were actually correct. So props to ChatGPT. But in any case, and I got it afterwards. And also, just to give you an example, this right answer. So, there are probably optimizations that you can do further, to be honest. Like, I don't think my code is the most optimized code, but that's the point, right? Maybe I shouldn't have to have the most optimized code to get accepted at 9.4 seconds. There's no margin of error, and that's why I got a TLE instead of wrong answer, and that's just kind of silly, right? Like, I don't know what the TLE is, and there's no way to know that either, right? Is it 10 seconds? maybe. Is it 15 seconds? Maybe. How Leetcode is just not giving us the tool to debug our time limit exceeded, to be frank, or even like way to think about it. But in any case, it's still my fault though, in the sense that, you know, yeah, I did misread it. If I'm like, I almost feel like if I did not misread it, I would have gotten it right on the first try. But that, even then, I might have complained a little bit just because it's so close that, well, this would happen otherwise. And also, I'm a little bit sad because if I did get it on the first try, if I didn't misread, I would have been top 6 maybe, top 7, something like this, right? Top 10 at least. Even if you want to do the one wrong answer because I misread, it would have been like 27, 28 minutes, would have been top 20 for sure. So I'm a little bit salty and sad about it. Anyway, okay. This rant has gone over 5 minutes, but I just want people to kind of hopefully learn from my mistake, because I haven't. I need to use C++ in the future, maybe on Leetcode. In any case, yeah. So at its core, this problem is not super difficult to understand, right? Basically, you start on the upper left corner, you have a cell, you can go up to some spaces to the left and some spaces to the right. The reason why this problem is a little bit silly, if you ask me, though I guess it's still hard enough. Let me refresh to see. So we're about an hour in and 382 people have gotten it. I don't know if that's high or not, because I don't know, I just don't keep track. Someone who keep tracks of these things, let me know if that's good or not, or hard or not. But in any case, the reason why I thought this one was a little bit awkward is because I think this is the same idea that we had last week with was it last week or 2 weeks ago maybe, on the let me see if I can pull it up. The reason why this is awkward is that this is the same problem that we did last week with was it the minimum reverse operations or the other one? Shortest cycle no, it's not that one. Is it this one? Oh yeah, it is this one. Yeah. Right, in that the idea here, and if you haven't done that problem, so maybe it's a spoiler alert. Sorry about that. But the idea is the same. Is that okay? Breadth first search is going to be too slow because there are too many edges, too many things to check, right? Meaning that, for example, if you're just thinking about going to the right, if the first cell can reach every cell, the second cell can reach every cell, the third cell can reach every cell, and so forth. If you count the number of true edges, it's going to be n squared, right? So if you just have like a one-dimensional thing, and it's like everything is 10,000, and you have 10,000 cells, or 100,000, I think, even, right? Yeah, 100,000, right? So that's a lot for 100,000 square. So the way that you can think about, the way that I did it, is to kind of have a way such that you can remove edges or nodes, depending on how you want to say it, to be processed in the future, so that you can process it only once, right? And like I said, there are probably a couple of ways you can do it. The way that I did it is by using in Python a thing called sorted list. If you're using C++, you can just use a multi-set. I guess I used a multi-set, but you don't even need a multi-set. You can use a regular set, I think. Like I said, I used ChatGPT to generate this. So I don't know. I mean, it's not going to be perfect for that reason. But in any case, yeah. So let's go. So basically, that's basically the idea. The number of cells is 10 to the 5th, but the number of edges can be a lot. So the way that we did it is by doing that trick. And then after that, it's just a breadth first search. This is, of course, exactly the same as the Q4 last week. So it's kind of, I don't know. Like maybe if they space it out, you could be like, oh, yeah. But I feel like it's a little bit awkward that it's a little bit awkward that it's just so close. It was literally last week, right? So this idea is probably fresh on people's minds. But in any case, yeah, so basically what I did is that for each row and column, I just keep track of a list of places that you can go, right? So this is, and maybe this is a little bit clear. For example, this means that on row X, you have the cell Y to map out X, Y. And then the rest of it is really just, we'll go over the hard part soon, but the most of it is just breadth first search, right? I'm gonna go over the breadth first search part, and we'll go over what changes from a regular breadth first search. Here we keep track of the best with R times C, some infinity value. We have a Q for breadth first search. We set the first cell as 1 because that counts as one cell. Remove some delete print statements. And then basically, as with most queues, we just pop from the left. If it's the last cell, we return. Otherwise, we process the next cell. And this one we'll go over in a second. But of course, we have to also remove 0, 0 from the thing. So the way that I do it is by using this sorted list. You can binary search for Y and then Y plus grid X to the Y, right? So what happens here, right? We can go over how this looks. Let's say you have a sorted list that contains 1, 2, 3, 4, 5, 6, 7, right? Something like that, right? And this is X is equal to 1, say, right? So then now X equals to 1. Let's say you could move 5 spaces. So then now for the first time, it's going to remove the first 5, say, right? And then now, let's say, later you process X is equal to 1, Y is equal to 2. So let's just this is Y is equal to 1, right? Maybe you have something like this, say. And because we removed this after processing, the next time this hits, it's going to just have 6 and 7. And so then it will never reprocess the numbers that you skipped. So that's basically the core idea of it, so that each number will only get removed once. And that's the core principle behind this thing. So basically, I binary search to the left, I binary search on the right for the bounds, and this is where I made my mistake because, well, I just misread it. It wasn't like I don't know how hardcore you want to call it mistakes, but I had something like this because I thought you could go to the left, but once I removed it, everything worked on the first time. So that's why I'm a little bit sad about it. But yeah, the reason why I have this remove away is because I think if you remove it in the middle, this will give you collection changed or something like this. So yeah. But basically, now we just keep track. We just look at for every Y that's in the row X, we just do basic check. Is this in the thing? Otherwise, I think actually this will always be true. Otherwise, it gets removed. But I mean, it's a cheap check. So we update, we do all these things, and then we remove. These are standard BFS stuff. Add this to the remove list, and then here for each remove, we remove it from the row and we remove it from the column. So then now next we do up and down. Again, I had this wrong in the beginning, that's why it's a little bit awkward, but otherwise this is the same except it goes up and down, or well, just down, right? And then we turn -1 afterwards if we don't early terminate. Cool. So what is the complexity here? Well, the way to think about it is that for each cell, and there are 10 to the 5th number of them. So for each cell, you're only going to add and remove from the queue once, and each one of them costs log of n, where n is the size of the thing, which is R times C. So yeah, because for each processing, we have 4 binary searches, and then each. So basically, if you look at it from the perspective of each cell, you get binary search 4 times at most when we pop, right? And then we also add twice and then remove twice, right? So that means that there's 8 binary search. So that's going to be n log n, because for each cell, it's going to be log n times. And of course, roughly speaking, maybe it could be more specific actually, because half of these are removed from columns and half are removed from rows. So maybe you can do some funky way of saying it, but still it's going to be R times C times log of R times C. Maybe it's log of R plus C if you want to or log R plus log C or something like this if you really want to be really dig deep into the binary search. So yeah, so that's pretty much it. C times log of R plus log of C, something like this. Maybe if you want to be really precise, I think that's roughly right. If it's wrong, then leave it in the comments. Maybe I'm a little bit wrong on that one. The reason is because you always only binary search on the rows or columns, so whichever dominates. If you want to be more precise about it, right? Because you don't search on both of them. But in any case, so yeah, that's pretty much all I have for this one. Let me try to make it smaller. Let me show you the top and then the bottom. So yeah, that's all I have for this one. Let me know what you think. Let me know, yeah, how you did with this problem. And that's all I have for this one. And you could watch me solve it live during the contest now. Hey, yeah, I'm actually back. I'm going to do another recording of another explanation of this one. I think actually the one thing that, if you kind of go through how I explained it, the way that I did it was by initially understanding the problem is going left, up, down, left, right, and I made some minor modifications to go right and down. But now that I think about it, I think the contest just ended. But now that I think about it, the proper way to do this, if you ask me, and it's kind of weird because, like I said, C++ and other solutions do work, like the one that I submitted. But there is a more optimal solution, and that's the one that I want to go over. The way that I would think about this is that, okay, let me pull in the paintbrush. Hang on. Let me do my drawing things. Okay, so basically the idea here is that, okay, let's say you have, well, the input, I suppose, right? You have something like this. And then the idea here is, the idea that I would think about is just that, I don't know that this is a great example, to be honest. Okay, let me do another one, right? So let's say this is 2, this is 1, this is 3, something like this, right? Maybe that's a little bit better. This is 2. And then the idea here, what I mean by frontier, is just looking at the boundary of where which one can go. So in a naive breadth first search, it's the same idea as the other one, but the implementation is a lot simpler as my earlier solution. The idea here is that for each row, we just keep track of how far we can go, right? So here there's a 1, that means that we can go all the way up to here. So we process all the way to here, and the idea is just that now when we process this cell, we don't start. Okay, maybe this is a poor example. Hang on, let me change the numbers a little bit. Let's say this is, let's just screw this example. Hang on, so the idea here behind frontier, and we'll start with the 1D example, maybe that's a little bit better. So basically the idea behind the 1D example is just that, let's say this is 4, right? 4, 2, 7, 5, I don't know, I'm just making random numbers, right? And basically the 4 now just means that we have to process 1, 2, 3, and 4, right? So then now we can just draw, you can have a way keeping track of this boundary of what we keep track of. So then now when we process this cell, we only go 2, but then there's no cell to be processed. So then this 7, well, we start from here now instead. So then it'll be, I have to do the math this way, but 1, 2, so now 3, 4, 5, I guess it goes over, but you get the idea. It's that now you just, for each row and column, you keep track of where to start from. Because basically you have this idea, and I think that should be good. I'm going to try to solve this live in front of you with this idea. We'll see if this works. Should be okay. It's the same idea, except for instead of using a sorted list, we just have yeah. Right, and then we don't need this anymore. Yeah. Okay, so then now we're trying to go, okay, so the start is actually going to be max of y, or row sub x. That's basically the idea. And then here, the right is just going to be, well, y plus grid of xy. Maybe min of this and c minus 1, I suppose, to keep it inclusive. And then here, now we can just go from range of left to right plus 1. And I don't have to change anything else, maybe the remove, because I don't think we have to remove stuff anymore. But then, and then after this, we can update row sub x is equal to right. So then the next time you use x, it's going to be just this. Well, maybe right plus 1 then. It's just going to start from there. That's basically the core idea. Let's try again for this one, for the other direction. And yeah. Hopefully this should be right. Okay, well, oh yeah, I forgot to change this thing. Yeah, well, this should be x plus 1, I think, and this y plus 1, but have a thing here, typo. And this looks good. Let's give it a submit. Hopefully this is fast enough. And this should be fast. I mean, this got accepted. And now you can see that this only took 2 seconds. So I definitely overcomplicated this thing a little bit. I guess I could remove this as well. So yeah, so just to fit everything on one screen. But this is a very straightforward BFS. And now we keep track of the frontier on the rows and the columns. Same exact idea as last time, but it takes advantage of the fact that you can only go to the right and down, and you can't go left. I don't even know if that's necessary, but I think that was the way that I wrote it without needing a proof. Where here, because we're only going down and right, you don't even need to do the proof as much. But yeah. Oh, and the time complexity is going to be linear time, linear space. Yeah, so yeah, that's all I have for this one again. So yeah, still though, still wish I got it quick. Like I wish the other one just got accepted, because it gets accepted in other languages, so it's a little bit, I don't know. Anyway, that's all I actually have for this problem. Let me know what you think, and you can watch me solve a live in contest next. I sells IK. Say what? Okay, let's read this again because I don't understand. So IJ, you can go IK, where K is less than 3 plus J. So it can go 1, 2, 3, 1, 2, 3, and then 2. Oh no, it's up to 2. So 3 to 2, and it's up to 2, right? Yeah, okay. Why is this hard? Because I guess naive wait for search is gonna be too slow. 10,000 cells, yeah, probably. So then now again we have to find a way to optimize this. Each cell should only needed to visit once, right? So that's same logic as last time, I think. How am I doing? No idea, I guess. Yeah, okay. No. Yes. I just need it to be sorted. Yes, I think. Again. Okay. And then now what? This buffer search should be okay. What were you doing there? So J is the number of things you can go. Okay. I mean, that's fine. Make sure that it runs first. Okay. Okay, so then now we want to binary search on y minus grid of xy. I had to add this stuff, I think. Okay, that's good so far. Okay. Now for new y in that should be good. I should do the performance about this, but it should be okay. How do I do this? I'm blanking now. Okay, fine. I mean, this should be. I don't need the thing. So then, best. If so. I need to do one more thing. This is not enough. Okay. This is right. This is so easy to mess up. Nope. What are you doing, right? Okay, and then now. Is it impossible if it's -1? Okay. Three, two, one. It's number of cells, right? So it goes to first one. So this is actually 1. YOLO. Should be fast enough, but if not, then I hate Leetcode. How can I optimize this? Each cell only gets visited once, so I don't get it. It's no hint or anything. And this is the problem with Python, is I don't know that this is, you know, the only thing that's wrong with Python. Alright, I asked. I don't know if this works. There's no sorted list in Java. I don't know how to do this in Java, the sorted list stuff. Maybe C++ has something like this. Right. But yeah, I don't know if I can. Do I have any typo or anything? I think that's the one thing that I worried about as well. But it seems like it should be okay. Just yeah, I mean, it seems like it's pretty empty, so I don't know. Alright, let's try C++ version. one. Of course, this is I guess 8 is probably good enough. Alright, let's see if this is fast enough. I don't even know if this is correct. If it times out again, then I have no idea. Okay, well, it just gives the wrong answer, but that's... Huh. I think this is a Leetcode thing, though, because everything just gets done once. So, how can it be too slow? Okay, well, maybe I'm just wrong, though. Probably should take out the print before I forget, but oops. I don't know how to solve this if this is not really, like, I don't know how to optimize this, to be honest. I don't really want to debug the other one. C++. I could see why this is getting slow down. But why? Tell me why. Maybe the constant is too slow. I don't know how many I have, but I guess it was too much. Yeah, I mean, it takes 1 second for almost a full case. That shouldn't be the reason. Is that any slower? Oh, whoops. Yeah, this is so annoying. I guess I could just do a case. With that timeout? No, I mean, it's fast enough. Do I need to early terminate? If that's the case, that's a little bit silly, but this is just impossible to optimize for, right? This is what's the wrong answer. I'm gonna be very sad. Let's give it a submit. See if that fixes it. Because you can't really tell with time limit exceeded, like how much I'm off by here. Because it's not one test case. We test the max case and doesn't look, so it's hard to tell. But only 1 people have gotten it so far, so maybe that's a little bit weird. No, 26 people got it. But I feel like this is it. Maybe there's some like minor thing that I need to address. But it's not like it's the wrong answer, so you just 10 to the 5th times log n for each one, right? So I don't know if this is a Python thing. What have my C++? I don't even know why this is wrong, actually. Is that possible? One cell seems okay. I actually don't know what the wrong answer could be, to be honest. Infinity should be long enough. It may not be efficient, but shouldn't get the wrong answer. That's the part I'm confused about. I mean, maybe that my Python code's wrong too, unless I misunderstood it. Oh, you only go to the right. Oh man, I messed up because I went to the left. Oh man. So that was wrong. Is this right now? Oh, let's give it a submit. I misread that one. Wow. Might still time out though, which would be very sad. Okay, wrong answer. That's good. That means that I'm changing something. Is that the first input? It is the first. Oh man, I am just misreading this then. Why is this? Oh man, now I misread this. Why is it giving me -1 though? Now I'm tilted a little bit. I misread this problem. I mean, it's basically the same, but still, I don't know why this is giving me -1. Why did I submit this for the wrong answer? Where am I trying to go? 3-3, right? This should include this one, but is it not? 0, 0, okay. 0, 3, 3, 0, 0, 1, 0, 2. Wait, what? It's up to, right? Oh. Whoops. We moved the wrong one. That's fine. I cost myself probably like a top 10 finish. Maybe. I mean, it may be that, you know, this is still wrong though. Or like this is still timeout because Python is silly. And maybe I should have just done in C++. I did misread this one though. Oh, there we go. Oh my god, I can't believe I misread this one. I really did have it. What did that misread cost me? Well, I don't know if I would have. No, I would have gotten it right because I didn't really change anything. Maybe a little bit early termination. Let's see how much time that was. 9 seconds actually. Wow, 9 seconds? That is ridiculous. That's just lucky, I think. What about the C++ one? Let me try. I can't believe I misread it. I mean, 12 minutes. And for things. It's kind of sad. Because 12 minutes, I got in 20 minutes. 20 minutes would have been top 10. I mean, okay, I mean, maybe I have to add in China, but still would have been top 10. Okay, so C++ works if I had not misread it. What a waste. Because I actually knew how to do it, but I just misread it. But the Python one is because that's the thing with Python, or not even Python, just like Leetcode Python, is that there's that uncertainty, right? Like maybe I could have spotted earlier if I wasn't debating the Python stuff, right? I think that's the penalty of Python, because I wouldn't have tried to do it, because this was the C++ solution, and I just kind of tried again. I don't know, these two are just kind of on tilt, I think. Well, this one I was trying to make an optimization, so it kind of cost me. I mean that. Kind of saddened by that one, because I really misread really cost me. I don't know if I would have gotten it right the first time. I mean, that was such a silly mistake. Would have been top 5, top 6 maybe, or whatever. Top 10 anyway. Would have gotten some swag. Why do people... And it's kind of Python related, I suppose, because if it wasn't for Python, I definitely would have, well, not even Python, like I said, right? It's because of Leetcode Python. Because I would have, if I was confident that I did something wrong. No, because shouldn't be time. I mean, it was very close, but that's the thing, right? Is that it should have had the opportunity to give me a wrong answer. And then if I got a wrong answer, even if I had misread it, if I had just gotten a proper wrong answer instead of time limit exceeded, maybe I could have misread read it, and then like maybe this time it'll be right. So I spent, even 27 minutes would have been top 15 or so. I don't know. I don't know what to say about this one, but I mean, some of it is just, Leetcode has messed up Python so badly that, people are kind of contemplating all these things, right? So, yeah. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, the description, everything you want in the comments. That's all I have. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.